Okay, good afternoon. We're going to continue with the guided examples of Classify Polygons. Okay, so yesterday we did this exercise right here with these three figures. So now we're going to do the checkpoint, okay? So again, to practice what we did yesterday, we have to tell whether the figure is a polygon and whether it is convex or concave. Okay, so I'm gonna draw these two figures. So remember, this is like you watching the lesson and you're taking the notes with me, and these notes are the ones that you're going to upload. Okay, so number one, we have this figure right here. And then number two, we have this figure right here that does this. Okay. All right. So first of all, number one, is this a polygon? Does each vertex intersect two sides, exactly two sides? Yes, this vertex right here intersects here and here. This vertex right here intersects here and here. So does this one, so does this one, and so does this one. They intersect two sides. So this one is a polygon. Yes, it's a polygon. Now we have to say if it's convex or concave. So based on what we learned, this one is convex. It's a polygon and it's convex. Okay. This one, number two, what do you think? Would this be a polygon? If we go back to our notes, let me go back to the notes that we have. What is the definition of a polygon? Let me go to the characteristics. For the polygon, we said that it is formed by three or more line segments. So, based on this definition alone, line segments, this right here is not a segment, okay? It's a curve. It's a curve. So, because of this, this is not a line segment. This is not a polygon. Okay? All right. That is example number one, the checkpoint. Okay? So we're still in example number one. Example one, the checkpoint. Okay? All right. Now let's go to example number two. Example number two. It says, classify the polygon by the number of sides and then we have to tell whether the polygon is equilateral, equiangular, or regular. Okay, so we're going to draw the next figure. Okay, It says classify the polygon by the number of sides. So the figure that we're going to draw is, we already know that it's a polygon, and this one is going to have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is how we start the polygon with 8 sides. We're going to have this like this, 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 this. We go down like this, and then we do this, and then we do this. Okay, so here we have this polygon. Now, if you see the example right here from the textbook, you can see that it has all these symbols. All right, so I'm going to copy the symbols. It has all these marks on the sides and on the interior angles. And then for the angles, we have these marks. Okay. So we already know, if I start counting here, I have 1, 2, 3, 4, 5, 6, 7, 8 sides. 8 sides. It means that this is a octagon. Okay, it's an octagon. Now we have to say if it's equilateral, equiangular, or regular. So if we see all the sides measure the same and all the angles measure the same, therefore it's a regular octagon, but we're going to write it as an explanation. Since all sides are congruent, it's equilateral, and all angles are congruent. It means it's equiangular. Therefore, it is a regular octagon. Okay, and that will be the answer. It's a regular octagon. Okay, I think that for your I think that for your independent practice, you're gonna have to work on the classification of polygons. So we're going to take some notes about the classification of polygons. Okay, so names of polygons, by the number of sides. Okay, so if it has 3 sides, we know it's called a triangle. If it has 4 sides, we call it a quadrilateral. Quadrilateral. And of course, by quadrilateral, we can have a square, a rectangle, a trapezoid, a rhombus. I hope I write this right. Rhombus. So square, rectangle, trapezoid, rhombus. All these are quadrilaterals. Then we have with 5 sides. If it has 5 sides, we call it a pentagon. If it has 6 sides, we call it an hexagon. Okay? If it has 7 sides, we call it heptagon. If it has 8, it's called octagon. If it has 9, we call it nonagon. If it has 10, we call it decagon. 11, undecagon. If it has 12, it's called the decagon. And I think I can only remember the names up to these numbers, okay? So after 13, so 13 or more, we go by n-gon, okay? So for example, 13 gon, 14 gon, etc. Okay? All right, so that's how we classify the polygons, by the number of sides, okay? We're going to need it for the next practice that you're going to be doing on Friday, okay? All right, then we move on to example number 3. Example number 3. This one is about find side lengths. Okay? And this is a word problem, and it says here, the head of a bolt is shaped like a regular hexagon. The expressions shown represent side lengths of the hexagonal bolt. The problem is asking you to find the length of a side. Okay, so this is the statement of the problem, and here we have the figure of the problem. It says that it's hexagonal, so it has 6 sides, so we're going to draw it like this. Okay, and then they're giving us this information about the sides. Okay, we have 4x plus 3 millimeters, and over here on this side we have 5x minus 1 millimeters. Okay, all right, so this is the shape of the bolt, of the head of the bolt, and the expressions shown represent side lengths of the hexagonal bolt. Find the length of a side. So we need to find out what is the measurement of one of the sides. Let me get my yellow highlighter. I don't know, where is it? Okay, I'm going to use the pink. So we need to find what is the length of one of these sides. So we need to look for, there must be a keyword here somewhere. And I see it right here. It says regular hexagon. And if you remember the meaning of regular, let me go to the vocabulary. Regular is when all the sides and all the angles, they measure the same. So it means that this side measures the same as this, is this, is this, is this, is this. And they're giving you these two expressions. So in order for us to find the length of a side, we have to write an equation. So that will be step number 1. Write an equation. Okay? Since I know that this side is the same as this one, I can create the equation with these two expressions, and I'm going to write it like this. 4x plus 3 is going to be equal to 5x minus 1. Okay? So they're the same. All we have to do is solve for x. If I solve for x, let me see what, I don't know what happened to my yellow highlighter. Okay, I don't know where it went. So all we have to do is find the value of this x or the value of the x here and substitute it either here or here, and that way we find the length of the side. But first we have to solve the equation right here. All right. So I don't want to deal with negative coefficients. So what I'm going to do is I'm going to subtract 4x here. Subtract 4x. So this is where we start solving like a regular equation. I'm going to bring down the 3. 5 minus 4x gives me 1x minus 1. And then I'm going to add 1, cancel, cancel. And 3 plus 1 is 4. And this equals 1x. And of course, this means that x equals 4. So I found the value of x. Now I can substitute this x anywhere I want. I'm going to substitute it right here. Okay. So I'm going to have 4 times 4 plus 3. So 4 times 4 is 16 plus 3. This gives me 19 what? Millimeters. So the length of the side, to answer the question, the length of a side is 19 millimeters. And this is the answer. Okay. This will be your answer. This will be your answer. Okay. All right. So this is example number 3. If you remember, we already did example number 2, which was classify over here. This is example number 2, classify the polygon. This is the second skill that we have. Then we have the third skill, find side lengths. And now we're going to do a quick checkpoint, okay, just to check what we learned, all right? So number 3 on the checkpoint. This is the checkpoint. This is where we check what we learned, okay? Classify the polygon by the number of sides. By the number of sides. And we have to tell whether is equilateral, I'm going to abbreviate, equiangular, or regular. Okay, so this is the figure that we have right here. It's like an upside down trapezoid right here. Okay, we have these symbols right here. Okay, so first of all, only these two sides measure the same. This one obviously measures different and this one measures different. Only these two angles measure the same. Only these two angles are congruent, so it's not equilateral, it's not equiangular, and it's not regular. Now, only by the number of sides we say that it's a quadrilateral. Quadrilateral. Okay? Number 4. The expressions for x plus 8 degrees and 5x minus 5 degrees represent the measure. Sorry, those are my dogs. Represents the measures of two of the congruent angles in example 3. Okay, find the measure of an angle. Okay, so this one is relating these two expressions to the measures of two of the congruent angles in example number 3. This is example number 3. No, example number 3 is this one right here. Sorry, this is example number 3. Okay, we have a regular hexagon, so remember, all sides and all angles measure the same. So it means that all of the angles right here on the inside of the hexagon measure the same. So I'm just going to draw it over here so that you have an image of what you're doing. Okay, we have the hexagon, and they're giving us these two measures of the angle. So this one right here, we're going to say that this one is represented by 4x plus 8 degrees, and this one right here is 5x minus 5. If we say that this one is regular, it means that all of the angles measure the same. Where we need to find the measure of an angle. If I know that all of the angles measure the same, it means that this expression is equal to this one, and I write my equation. Okay, 5x minus 5 equals 4x plus 8. So I need to solve for x. I'm going to subtract 4x, cancel, 5 minus 4 is 1x, minus 5 equals 8. And then I'm going to add 5. These two get canceled, and 1x equals 8 plus 5 gives me 13. So x equals 13, okay? So this is the value of the x. So now I can substitute the x, this value, in any of these two expressions, okay, to find the measure of the angle. I'm going to substitute it on this one right here. So 4 times 13 plus 8. So let's do this arithmetics. 4 times 3 is 12. We have 1. 4 times 1 is 4. Más una, plus 1. That's 5. Plus 8. And this gives me 52 plus 8 gives me 60 degrees. And the measure of the angle is 60 degrees. Okay? So those are the examples. This is the end of the guided examples that we have from the textbook. Okay? This is where our lesson stops today. So remember, you watch the video, you take all these notes, you highlight, you do the operations. Your notes have to look exactly like mine here. Okay? And you have to upload tomorrow. Okay? And then Thursday, we're going to start with the practice, okay? We're going to start with practice A. Is going to be a guided practice, okay? All right. So remember, you have to pay attention to the video. Don't just watch the video and copy like a robot, okay? Because that can be done by a kindergarten student, by a kindergarten kid. Anybody can do that. But you have to pay attention, because on Monday, I'm going to give you your first quiz, all right? So you're going to be working on these videos. You're going to be working on these lessons. This is easy. This is something very simple. We do the guided exercises. We do the guided practice on Thursday. And then Friday, you do independent practice. And then Monday, I will give you a short quiz, okay? All right. So thank you. And don't forget to upload your work, okay? Your photo with your notes, all right?